Today we're going to start Unit 5, which deals with quadratic functions. And our focus today is going to be vertex form. But before we can get started, I know before break we talked about, I mentioned the term quadratic, some of you are wondering what that was. Quadratic is going to be a function with an exponential power of 2. And there's 3 different forms that our quadratic functions can take. The first one is standard form. And standard form is when it would be y equals ax squared plus bx plus c. And in this case, our a, our b, and our c, these are going to be numbers. They're not going to be variables like our x and our y. An example might be y equals 2x squared minus 3x plus 4. Now they can be positive and they can be negative, and so that's just an excellent example. The second form, which is what we're going to deal with today, is vertex form, which is y equals a times the quantity x minus h squared plus k. And in this case, again, our a, our h, and our k are going to be numbers. And an example could be y equals 2 times x minus 4 squared plus 3. And this might look somewhat familiar to you, that if we were to take this plus 3 and subtract 3 from both sides and put it over here, it would look very similar to point slope form from last trimester before break. So just be aware of that. It operates in the same way, that because this is x minus 4, it's not going to act normal. And in this case, our vertex would be 4, 3, because we have this x minus 4, and then that plus 3 ends up being our y. The last option is factored form, which would be y equals a times the quantity x minus x1 times the quantity x minus x2, where x1 and x2 and a are all numbers again, and x1 and x2 are going to be our x-intercepts, which we will talk about when we get into factored form in the next couple of lessons. So the first thing we need to be able to do today is we need to be able to graph a parent function. And we call this equation y equals x squared the parent function because it's basically the basis for all other functions, just like your parents are the basis for all of the kids in your family. They are the creators of everything else. This is the most basic form. So the first thing we're going to do when we talk about graphing a parent function is we're going to create a t-table. So I have one provided for you, choosing both positive and negative x values. And the reason why we choose both positive and negatives is so we can see what the graph does on both sides of the y-axis. So I usually like to stick simple and go with -2, -1, 0, 1, and 2. Now when we graph quadratic functions, you'll understand in a little while why we require at least 5 points. Now step 2 is going to be to substitute into the function to solve for y. So if I put -2 in for x, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Now, the nice part about this is you start to see a pattern which helps us out here. And then finally, our third step is going to be to plot and connect these points. So when we start off here and plot these points, we've got -2, 4. Remember, go left or right before you go up or down. -1, 1, 0, 0, 1, 1, and 2, 4. Now, if I go to start and follow our directions from last trimester and go to connect the line, I connect the line straight out and it's not going to go through any of the other points. As a result, same thing if I go back out this way. It's not going to connect out. So therefore, because of that, we need to actually make this curve. Now, it's going to curve up and up and up in a similar fashion. Likewise, it's going to come here in a similar fashion and almost make a U shape. Now, I did go in 2 separate directions, but it does actually form a curve And so if we actually made this curve from left to right, we'd come down, and then at 0, 0, we curve around, and that is what we call our vertex. It's the point at which the graph changes directions. It is a smooth curve. This here, as we mentioned, is our vertex. And this has a special name to it. Quadratic functions have a graph that is called a parabola, which I have mentioned in class before. And this is the basis for all of our graphs, and it gives you the basic overall shape of what all parabolas are going to look like.